Today's video lesson, we're going to talk about counting atoms. So this is the ability for us to look at an element, determine how many protons, electrons, neutrons it has, as well as be able to sort of represent or communicate other relevant information. So the first thing we're going to look at is what's called the atomic number. And the atomic number is represented by the symbol Z, and it tells us the number of protons that are in a nucleus. Now, this is very important because this is truly the identity of an element. As protons change, the identity of the element changes. If electrons change or neutrons change, it's still the same element. Okay? That doesn't change. For right now, also we'll say the atomic number is going to tell us the number of electrons, but that will change. The second thing we're going to look at is what's called the mass number. Now the mass number doesn't have a symbol. It is just truly the number of protons that are in an element and the number of neutrons that are in a nucleus. So if we're looking at two things here, the mass number is equal to the atomic number plus the number of neutrons, or another way to say it is the number of neutrons in an element is equal to the mass number minus the atomic number. So if we're given a particular element, we can figure some things out from that. Now let's talk about isotopes. In isotopes, we have elements that, first of all, have to have the same number of protons. There cannot be a difference. What is changing is the number of neutrons. So an isotope has to have the same number of protons, but the number of neutrons can change. Does every element have an isotope? No. Most aren't very common. Usually there's one form that's the majority, and there are others that have very, very small variations to that. We will talk about a couple elements that are unique in terms of their isotopes. For example, if you turn to page 82, if you happen to have that in your book, you will see some different isotopes listed, which we'll talk about here in a little bit. Now, what we're going to talk about next is the nuclear symbol. This is one way we're going to write the various information depending upon what we're given. So the nuclear symbol for an element is simply the mass number written over top of the atomic number next to the element symbol. So right here, this is the nuclear symbol for carbon. This is the nuclear symbol for oxygen. So from this, we can figure out the number of protons, electrons, and neutrons. Here in carbon, the bottom number represents the atomic number. The atomic number equals the number of protons. So 6 protons. Also right now, because we haven't said otherwise, the atomic number also equals the number of electrons. Now the number of neutrons, remember by definition what the mass number is. Mass number is equal to the number of neutrons plus protons. So if the mass number is 12 and the number of protons is 6, the number of neutrons are also 6. We come over here to oxygen. Again, I think we can see this pretty easily. 8 protons, 8 electrons, and 8 neutrons. So we should be able to, either way, given an element's information, given the number of protons, electrons, and neutrons, we should be able to write the nuclear symbol, or given a nuclear symbol, we should be able to determine the number of protons, electrons, and neutrons. The second way that we are going to write or represent the number of protons, electrons, and neutrons in an atom is what we call hyphen notation. In hyphen notation, we have two choices here. One, we can just simply write the element's name followed by a dash and then the mass number, or we could shorten that up and put the element symbol followed by the mass number. It is not the atomic number. And people sometimes get these confused. So we have three examples here: aluminum 26, calcium 40, or C12. So first of all, we know it's aluminum, we know it's calcium, we know it's carbon. So because we know the identity, we know how many protons they have. Okay? We look on a periodic table, the atomic number for aluminum is 13. The atomic number for calcium is 20, and the atomic number for carbon is 6. So right off the bat, we know what the protons are. We also know what the electrons are. They're the same as protons. Now that'll change here in the next screen, but again, one more time, they're the same. Now if we want to find the number of neutrons, okay, this number here is the mass number. Mass number minus protons gives us the neutrons. So 13, 20, and 6. Now you might be wondering, well, in all the examples, they're the same. Well, what starts to happen is after calcium, the number of neutrons start to change more rapidly. And you will see a greater discrepancy the farther down we go on the chart. One example we'll just do here, let's say I pick copper. So let's do copper's mass number. Okay. Say we're given a situation here, copper's mass number is 63. That means the number of protons for copper is equal to 29. The number of electrons is equal to 29. And the number of neutrons is the difference between that, which we can see in this example is 34. So that, again, we see they start to be different as we move on. All right, last thing. Well, what if the number of protons and electrons aren't equal? How do we figure that out? Here's what we have. If the number of protons and electrons are not equal, then first of all, it's not called an atom. It's called an ion. Okay? So an ion is an atom with an unequal charge. So that means that we have the number of protons are not equal to the number of electrons. One thing we want to remember here is if we're talking about protons, they have a positive charge, and if we think of electrons, they have a negative charge. Now for some people, this is kind of tough. We've got to think in terms of pluses and minuses, almost like a number line. So let's just say we've got two scenarios here. Scenario number one, we have an atom that has 6 protons and it has 5 electrons. Its net charge is a +1. It has one more plus than a minus. If we look at the second example, an atom that has 6 protons and 8 electrons has a net -2. And actually, we'll start to do this more this way, a 2- charge. So that's its net difference. It has 2 more electrons than it does protons. So we need to kind of watch out for, is there a charge in an atom? Okay. So if there's a charge in the atom, then again we're going to use the term ion. So last example here. Let's say we have a carbon atom that has 6 protons, 6 neutrons, and 8 electrons. Well, if it has 6 protons, it has 6 pluses, it has 6 neutrons, and it has 8 electrons, its charge is a 2- because it has 2 more electrons than protons. Let's say calcium. We have an atom of calcium that has 20 protons, 20 neutrons, and 18 electrons. It has an overall charge of +2 because there's 2 more pluses than minuses. And the third example, let's say we have a sodium +1 ion. A sodium +1 ion, that means that there is one more proton than electron. So as you look at different examples in the book, that's what we've just got to be familiar with. What's the identity of the element? Once we know the identity, we know protons. If we know protons, we can probably figure out electrons, whether or not there's a charge or no charge. And then the last remaining piece would be the number of neutrons, which we would get from the mass number.